Challenge. This one's a level 7. We're going to do it in Python. And as always, you should definitely try it out on your own before watching the video. That's the best way to learn, is by banging your head against the wall and making your own mistakes and just getting the reps in. Coding is a lot like learning an instrument. So with that in mind, there will be a link to the challenge in the show notes if you want to try that out. And then you've always got the video to fall back on if you get stuck. As always, please like and subscribe. That helps keep me going, helps keep you informed. Once I get through these Python challenges, I'm trying to do 100 of the level 7s, and then I'm going to move over to JavaScript. So if you're excited about that, just kind of hang tight and subscribe so that you're in the know. So with that, let's go ahead and get started. So we have a Coprime validator. This is the name of the function. So we're going to write a program to determine if two given numbers are coprime. A pair of numbers are coprime if their greatest shared factor is 1. So for example, 2 and 27, the factors of 20 are 1, 2, 4, 5, 10, 20. Factors of 27 are 1, 3, 7, or 1, 3, 9, 27. The number that they both share is, or the greatest factor that they share is 1. Therefore, they are coprime. Here in the other example, 12 and 39, their greatest number that they share is 3, so they are not coprimes. Okay, so I think this can be probably like a return true or false kind of thing. So we have two numbers, n and m, and I want to try those out over here in our scratch paper so that we can at least visualize what's going on. So we'll start off with two numbers that are coprime, and that was what, 20 and 27? And so what we're going to do is we need to have a function called getFactors. So getFactors takes a number and returns basically we're going to have it return a set of the factors. So what I'll do here is, let's say factors will be we'll start it off with a list. And so we'll say for I in range, we'll start at 1, we'll go up to the number plus 1, whoops. And so if the number mod I is 0, in other words, if they're divisible, okay, so remember mod gets you the remainder. So if I do 20 mod 10, right? 20 divided by 10 is 2, remainder 0. So you're going to get that remainder there. So anytime you have a 0 as the remainder, they're divisible. So what we'll do is we'll append that. So we'll say factors append I, okay? When we're done with the for loop, we'll return this as a set. So this will be kind of cool to sort of see here. So what I want to say is in factors is equal to get factors for in. Okay, and then the m factors is going to be get factors m. Okay, and if we look at the m factors, okay, we have another set. Now here's the cool thing: if you have two sets, I can get the numbers that are in both. And if the only number that is in both is 1, then they're coprime. So watch this. I'm going to do in factors intersection m factors. This is a cool thing that you can do with sets. That's why I wanted to write a function that returns sets. So 1 is the only thing that they have in common. Now watch what happens if I change it to the other one, which I think was 12 and 39. So let's see what that does. So I'm going to change this one to 12. We'll change this one to 39. We run our cells. Okay, so we run that. Okay, so there's the 3, there's the 3. Now look at that. If you have if the length of the intersection is more than 1, then they're not coprime, okay? So what we'll do is get this stuff over here. I need my function, and it's perfectly fine to have two functions within Codewars. So I'm gonna do one like this. This is the only one that's being tested though. So then we'll copy and paste some of this code over here. So we got in factors, and then we've got m factors. And then we're going to return if the length of the intersection m factors is the length of that intersection equal to 1. If it's equal to 1, they're coprime. If it's not, they're not coprime. So I need to make sure that we're returning booleans here. Yeah, so we're doing true and false. Okay, so let's test this out. And looks like we got it. Let's do a full submission. Awesome, not bad.